Okay, this is going to be an instructional video on what is slope. If you ever walked up or down a hill, then you have already experienced a real-life example of slope. Keeping this fact in mind, by definition, the slope is the measure of the steepness of a line. In math, the slope is defined from left to right. There are 4 types of slope you can encounter. A slope can be positive, negative, zero, or undefined. So here is the positive slope. See how it goes up from left to right? This one goes down from left to right. So this one's positive, this one's negative. This is zero slope. It's just a flat line. Zero heartbeat, zero slope. This one is up and down. It's undefined. Okay? You can only go up or down. All right? The next one, here's one method of finding the slope of a line. Remember, slope is a measure of how steep a line is. That steepness can be measured with the following formula. Rise over run. So slope equals rise over run. Now the rise is when you go up how many points or how many marks on the y-axis. And then the run is how you go from left to right or right to left, depends on how you end up doing it. That's on the x-axis, and that is the run. Okay, so an example for this situation, we see that the rise is 2, right? And the run is 4. So the slope, 2 over 4, or 1/2 after simplification. Since 1/2 is positive, you are going uphill. Every time you go up 1 unit, you cross or horizontally to the right 2 units. But now this is where how you get it. So the rise is you're going down is -2. And then when you go to the left, that's -4. But remember, 2 negatives make a positive. That's why it becomes 1/2. Okay? I just want you to remember that, because when you go down, it's negative. When you go to the left, it's negative. But negative divided by negative is a positive. For this situation, the rise, you're going down -5, and you're going to the right +3. Okay, because you go to the right, it's positive. When you go to the left, it's negative. When you go down, it's negative. When you go up, it's positive. So here we have -5 over 3. Since 3 over 3 is negative, you are going downhill. So this is a negative slope. Okay, so this is negative. Every time you go down 5 units, you go horizontally to the right 3 units. Okay, so this is the first page. If you need to pause it for a minute and go to the next page, that is okay too. The next one, we're going to find the rise and the run for each solid line. So we have 1, and we are going down, so that's -1. So rise, remember, is on the y-axis, and then you're going to the right for 5, because you do rise over run, so the slope is -1/5. Then we have this one, rise over run, so it's going down -3, and it's going to the left -2. Okay, so notice this was a negative, so we know that's downhill. Remember this, the rise is -3 over -2, so -3 over -2 equals 3 over 2. So remember, 2 negatives gives you the positive, and that's why you have the positive slope leaning toward the right. Now, when you go down here, we are going to start at point A, and we're going to get to point B. So then, if we want, we're going to go down 2 boxes, and this is scaled, and this is where it's important to remember how it's scaled. So this is down 1, 2. So the rise is -2 because we're going down, and then to the right, 1. This is 1, 2, 3, 4. So we're going to go 1, 2, 3. So the slope is negative 2/3, negative 2/3. Okay? Then we are going to go up and do this one. So this one, remember you do, the rise is on the y-axis. So now we're going up to where this line connects. So we go up 2, and we're going up, and then we're going to the right to B, and this is all, I want to make sure that we are on the right scale. 1, 2, 3, 4. And this is 1, 2, 3, 4. Okay, so we're going to go over 1, 2, 3, 4, 5, 6, 7. So 2/7. Okay? And if we wanted to check, we can always connect these 2 points. And this showed us it was a negative slope, and it is. It's leaning toward the left. And then if we look at this one, we connect the points. It is a positive slope because it's going up to the right. Okay? Now the next one we're going to do is we're going to use the coordinate plane below, and we're going to connect the points using a straight edge. So I'm going to take the ruler, that's what a straight edge is, and we are going to draw a line through A, B, and C. Okay, so I'm going to draw a line, and then I'm going to put an arrow on each end. That means it continues on either side. Okay, so now we want to find the slope between points A and B. So remember, we have to make sure that we know what the scale is. It's -1, -3, -5. So we're going to go 1, 2, 3. So that's where it connects to this line. So this is -3 is the rise. And then we're going to go to the left to connect. And again, these are 1 points each. One block is 1 point. 1, 2, 3, 4. So this is -4. So if we go -3 over -4 equals 3, 4, which is positive, which makes sense because this is leaning to the right, positive. Now find the slope between B and C. So now we're going to go up, and we already distinguished these are worth 1 point. 1, 2, 3. So we're going to draw the line that goes up to here, and then we're going to go to the right to that point. So 1, 2, 3, rise is 3. 1, 2, 3, 4. It's 3/4. Okay? Now, if we want to do the rise of A and C, we're going to go 1, 2. I'm going to make a little dot here so I know. So we go 1, 2, 3, 4, 5, 6. So the rise is 6. And then we're going to go over 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to go 6/8. And we can simplify this. So if we take 6 and we divide both the numerator and denominator by 2, we get 3/4. Okay? So this is simplified. And if you can, they like you to simplify. Okay? So here we had the first one, then the next one, just so you can see it, and then the last one. Okay, so if you look at this, you know that all these, even though they look different, like this one is twice the size of this one, but when you simplify it, it has the same slope, and they're all in the same line. And so even when you have to go down and over, when you divide it two negatives, you get a positive. So just notice that these are all the same slope. They're just calculated a little bit differently. Okay, so now what can you conclude about the slope of this line looking at your results in parts through B? The slope is the same for all. the same for all points, for all sets of coordinate points. And then we have, starting at C, find a fourth point and make it match. So if we go to C and we know that we can go up 3 and go over 1, 2, 3, 4, we know that this would have the same slope because it's on the same line. So find a fourth point, which I'm going to call 8, and this is 5. Okay, so we're going to say 8.5, and I used the rise over run, so I used up 3 over 4, which was the rise over the run, to calculate the next coordinate point, which was 8, 5. Okay, and let me pull this up so that you can see this in case you need to write it. And then pause it, go back, check your work, and this is the end of part